Hi, everyone. Thanks for joining us. And we are live with our very first speaker, Andreas Falk, who is going to speak about shift left security with a security test pyramid. He has been working on enterprise application development projects for more than 20 years. Currently, he is working as a managing consultant for Novatech Consulting, located in Germany. In various projects, he has been around as an architect, coach, and a developer. His focus is on the agile development of cloud native enterprise Java applications using the complete Spring platform. As a member of the OWASP, he likes to have a closer look at all the aspects of application security as well. Andreas is also a frequent speaker at conferences like OWASP AppSec, Spring IO, Cloud Foundry Summit, and many more. Thank you so much for joining us, Andreas, and the stage is all yours.
Okay, thank you for having me. So glad to be part of this. So we will speak about shifting left security with the security testing pyramid. So as mentioned, so I was already introduced. I would just add that I'm not only member of the OWASP for several years, since several years, but also take part of different communities like also the OpenID Foundation or the IETF. Because I'm also doing lots of stuff into identity management, in addition to application security. But that's the last advertisement slide for me. We only have 30 minutes time for my talk, but I will also show some sneak preview of some small code demos as time allows. And if you want to have a deeper look into how to write tests, how to write security tests, I have a small application built up by Spring Boot that stores bookmarks with a service, providing a REST API for that. And I've put in an insecure branch and also a secure branch and doing lots of security testing to show how that works, so in practical. So if you want to go deeper into that, just go to that URL and you find plenty of codes there. So let's dive in. So for most developers, this kind of testing pyramid should be a well-known picture. So for those that are not that familiar with that, at the bottom you see unit tests, so the so-called programmer tests. So these are the main tests that developers tend to write each day. So this is kind of a safety net for a developer. So if a developer changes big things, then he always can run these safety net tests and get a fast feedback if my change did break anything. So these tests typically run pretty fast. So you get feedback in some seconds, 1 or 2 minutes, depending on how many unit tests you run. So this should be most part of testing of the developer. Next layer would be the service layer tests. So here you find typical integration tests like your Spring container based test or running in an application server container, stuff like that. So you need typically some runtime services for that. And on the top level, you have the so-called workflow tests, or also sometimes called acceptance tests. These are the tests that take the most effort to write, that are really slow. You get a slow feedback. You should not typically put that in your CI/CD pipeline. Otherwise, this pipeline might run for 2 hours, which is pretty long as a fast feedback if you're just doing some additional commit. On the top level, you have the manual tests like explorative testing and stuff like that. So these take personal resources, and because of that, you should not have too many of them. But what about security? We did not see anything about security in this testing pyramid. And that's what I'm exactly talking about today. So we also have these terms like DevOps, DevSecOps. And so for me, the sec in DevOps is just silent you find plenty of talks about that topic already on the internet. So you also find, like in my title, shift left security, shift right security, shift outwards. I would say I don't care if you shift left, right, outwards. Just start putting security into your complete development lifecycle. So on each and every phase of your development lifecycle, independent of you are doing waterfall or you practicing Scrum or Kanban, just put security into your daily Scrum meetings, into your plannings, into your refinement meetings for user story writing, and also for the testing. So today we concentrate a bit on the testing and the requirements engineering part. So my message here, just start doing things independent how it is named actually. So the first thing we have to talk about is, if we try to write security tests, how to derive security tests. Andrew mentioned, for example, the OWASP top 10 in his keynote. So as he also mentioned, OWASP top 10 is the first document most people get to know of the OWASP, but it's not the most usable document. So I also get very often in my projects managers telling the developers there, so make your project OWASP top 10 compliant, so it should fulfill the OWASP top 10. I always tell the managers that's complete bullshit. Developers should not fulfill any OWASP top 10, so it's not certifiable or something like that. And always also try to link them to other documents like the Application Security Verification Standard, which is a really great document. I can also recommend it to each and every developer, requirements engineer, architects, and business analysts, to everyone basically. So you get plenty of requirements regarding security there that you can apply for your project. A second guide is also quite useful, especially for creating tests, the so-called web security testing guide. And with these two documents as inputs together with your usual business requirements, you can easily derive security requirements from that. And you get concrete requirements and not just the usual sentence. So please make the project, the application secure. No developer has any clue what to do if you just tell them make it secure. So we need concrete requirements and also concrete derived tests from that. Also very useful is always to perform threat modeling, look at your application, draw data flow diagrams, and just, for example, play the elevation of privilege game. That's all for free. You find lots of threats on your model, and then you can also derive requirements and new tests from that. So now that we have understanding how to derive tests, so this is an example and an outcome, some part of the application security verification standard. So here has different fields, like, for example, for architecture, design, and also threat modeling as mentioned. Then for the typical things like authentication, session management, access control, and so on. For every chapter here, you find the concrete requirements. You also find concrete ideas, how to verify it, how to write tests for that. So it is really helpful for requirements engineers and also for developers. And now we just jump in. What to do at first stage at the unit test layer. So typical tests you write or typical tools you use at the unit test layer are at first static application security testing. So doing your static code analysis. So this is a point that I find very often in projects, luckily today. So most serious development projects nowadays use static code analysis tools, like open source ones, but also commercial ones. They also use tools to check the third-party dependencies for known vulnerabilities, like, for example, the OWASP dependency check or if they are using Node.js, they just perform a npm audit fix. So that's also much more improved nowadays. If you go into Kubernetes, then you're typically also doing what is called a container image scan, which is also part of that level already. And then you typically can do unit testing. And you can do different things already on that bottom stage. So you can write tests for secure architecture, for example. If you use frameworks like ArcUnit, then you can easily write also architectural facing tests that prove different things regarding security. For example, in a Spring Boot application, proving if all the authorization annotations are on the right place, if you don't have missed one of these important annotations, for example, or error handling. So just check what are return values of exceptions that have been thrown. Do the exceptions include too many sensitive information to be put on the front end? Also, the typical unit testing, like bypassing business logic for malicious reasons, you can also test that. So you should usually do lots of negative testing in your unit test. Not only test the happy path, but always test the negative ones as well. You can also test for broken authentication, like, for example, verifying that you have a good password policy in place to check registering users with strong passwords, for example. And you can also check for input validation. So lots of things you can already check on that basic level. So I mentioned static application security testing. Here you find the typical tools like SonarQube, like Spotbugs, SemGrep, OWASP dependency check. For infrastructure code, you find tools like Checkov, or for Terrascan, especially the Terrascan tools. So all these tools are free to use. Also, Trivy is free to use for container image scanning. Should just put these tools in your usual development life cycle in every day's work. Put that as near as possible to the developer's workplace. So it's easy to use by every developer, and also put it as automatic check into your CI/CD pipelines. So we already mentioned the OWASP top 10. So this is one example that I just took out of that to show some sample security tests. So in that case, how to avoid broken authentication by using very bad passwords, like the most famous password 1, 2, 3, 4, 5, 6, for example, or the password. Or just use your username as part of the password. There are some preventions mentioned here already in the OWASP 10, but the much better document is again the ASVS. It clearly states what security requirements you have typically for passwords. So they should be at least 12 characters in length. You should provide a possibility to even have really long passwords. So there is no reason to restrict passwords just having 20 characters in length. So it can be possible to put up to 128 characters as a password. With the password managers like KeePass and stuff like that, it's easy to generate secure passwords that also have really have many characters. Also check that password truncation is not performed, for example. In Java, we have a good framework, for example, for that, for creating password policies. It's called Passai, that are included in that mentioned sample project. And I just jump over to a first short demo I have prepared. So this is the project I've mentioned with lots of tests. It has some main Java code that's not too big. So a typical 3-layered architectured application with a REST API, a service business logic layer, and a data access layer with authentication, with username, passwords stored. And here we have some tests, like for example, that we mentioned architecture tests for security. So here you can have, for example, input validation tests. So for those of you that are know the bean validation framework in Java, they should be familiar with that fluent rule that I formulated here. So this architecture test is about testing that each persistent entity has at least one of these predefined constraints on each and every attribute, just to check for input validation. So you should not forget any of these attributes, at least to check the basic things like it should not be empty, or for size, or if you have an email, you can check that, or if you have a string, you can also use regular expressions for checking min-max values of numbers, for example. And with that architecture test, you can prove that you've done your job at basic level, just to put some constraints on each and every attribute. Same, you can also have tests to check for that you don't do low-level GDBC operations, like not using prepared statements, for example. So this checks for direct executions of the Java SQL package, for example. So it's only allowed to use, in that case, Spring Data prepared statement functionality provided by the framework. And with that architecture test, you can also easily check that developers are not using illegal direct access calls. Also for authorization, you can also easily prove here if you have a service defined. Then if you're a Spring developer, you should know that a pre-authorize annotation to check authorization on each and every operation level. Here you can also easily check if a class name ends with service, for example, and is annotated with the Spring service annotation, like for example, here in that case, then it should have pre-authorized annotation at the class level or at the method level, at least. So this have been some architectural tests that you can do on the unit test level, but you can also already do tests checking for password requirements. So as you can see in the comments here, I've written tests especially checking and proving if the ASVS requirements are done in a correct way. So some tests can only be tested in an integration test. I also noted that. So for example, if your passwords are at least 12 characters in length, you can easily test that with that bean validation factory that you can instantiate in a unit test. You can also test for pretty long passwords, that these are really permitted in that case. Also, you can test that password truncation is not performed, which is always bad. So if you truncate it silently and the user then comes next time to your application, tries his well-known password, and this password does not work, so that is really annoying for the user. So it should still be equal after validating the password. And according to the latest NIST recommendations, you even can use emojis, UTF-8 characters, complete Unicode characters as part of your password. You can also easily check if that is really possible. Just put some emojis as an example here. And you can also verify passwords against a set of breach passwords. I've written also some parts that has a list inside with the most breached 10,000 passwords, for example, and it also checks against that list if one of these passwords is used, and that will also be denied and will be proven by that test. So this was a bit of unit testing in that stage. You can also use the testing guide, so it also has helpful hints how to test for password policies. Next layer would be the service test layer. In the service test layer, you can even test more things, like checking the input validation on a real REST API service with Spring, for example. You can test authentication, you can test authorization. Authorization can be tested on different layers, so it's always a good idea to also follow the defense in depth pattern here. So not only having authorization done on the web UI level, but also should be done again on the service operation level, on the business logic, and maybe also on the data access level again. So the more levels you add, the more secure your authorization is as well. And you can easily also write automated tests. I have no time to show them all, but you find all these tests inside the project, and you can check out that for yourself. You can also test session management. Are the session IDs random enough? Also checking for output escaping. Am I just reflecting input directly to the output? And also you can check for SQL injection. Why not just putting famous injection patterns like the OR 1 equals 1 stuff as a payload inside your REST APIs and see what happens. So if it just returns then 0 results when you put that inside, that looks good. But in the case, if it returns maybe 10 items for putting in such a malicious content, then you may have some SQL injection problem at that stage. Also test for security misconfigurations, like for example, if you have a wrong course policy with the famous wildcard star inside, so that each and every front end can just put AJAX requests to your backend. This is a typical thing you can also test automatically. So here the example would be access control design to test it automatically. Especially for the testing guides, you should always test for your static roles, for administrative functions, like for example, but also test for resource-based authorizations, like for object-based. If user A can access object A, but user B cannot access object A, for example. So you should do both kind of authorization tests. So the highest layer is the acceptance test layer. So that's the last part already. So that's the typical layer where you put in dynamic application security testing. In the keynote, there has been mentioned already the OWASP tool, which I can also strongly recommend to use that. And there's even a commercial company now where also Simon Bennett is working now, the founder of OWASP. And they even provide some bit more convenience. But for most projects, I'm sure that OWASP would be enough to use for dynamic application security testing. You can also use the commercial thing like Botswicker Burp Suite. That's the typical thing that professional pen testers use. But also specialized tools like open source tools like SQLmap or Nmap can be used at that stage. So just put that also inside your CI/CD pipeline in your nightly builds if it takes too long for the usual CI/CD build, and also put the OWASP IDE next to the IntelliJ Eclipse IDE the developers are using. So it should be on the desktop just next to your usual IDE like IntelliJ and stuff like that, or Visual Studio Code, what else. So this is the important part here. Just try to break your own application before any attacker does that for you. So for SAP, they also even provide some predefined Docker containers to do automatic scanning in 3 variants for putting it into your CI/CD pipelines. You can easily use the baseline scan variant. This runs pretty fast. It just does some passive testing, checking if your security headers are in place, if you're using weak mechanisms, authentication mechanisms like basic authentication. So these are the typical results you get from a baseline scan. So this can easily just run with CI/CD, has a fast feedback. For doing scans against your typical REST APIs, there's a specialized variant like the API scan. Just create a documentation for your REST API for the Open API standards, which is done by some Swagger frameworks. Then provide that Open API documentation as an input to the SAP API scanner, and then SAP just scans all provided URLs of your REST API automatically with some predefined passive and, in this case, active scans. So it just tries to do SQL injection, cross-site scripting, input validation errors. So it just tries all the bad stuff happening when an attacker tries to hack your REST API. This, depending on the amount of URLs your REST API has, this might be useful to run it in CI/CD system, but if it takes too long, then just move it to your nightly builds, for example. The full scan clearly should only run in nightly builds, as the full scan just runs the full-blown passive-active scan rules against your application, and depending on the size of your application, can run pretty long. It also optional does a Ajax spider scan. So if you're using single-page applications, then it just uses Selenium as a base framework and just tries to find each and every page in your single-page application to follow the usual links and forms and stuff like that. With that, you even can also detect URLs that may not be part of the Open API spec. So just go to the over-SAP page and try to run the variant that fits to your application. So this is already the summary of the talk of today. So we again see the different layers of a testing pyramid. So we have shown that on the bottom line, you can use your static application security testing tools. There are plenty of these. In my project, usually we have SonarQube and Spotbugs, for example, and the OWASP dependency check in place. With these tools, we typically already find plenty of ugly stuff, not only security-wise, but also regarding clean code recommendations and stuff like that. Then also write tests for input validation, for making secure that also your architecture is secure. Testing for broken authentication, password policies. Then on next level, you can even do more input validation tests, test for authentication. In Spring, you can even test for JSON Web Token-based authentication, certificate-based authentication, basic authentication, form-based. So each and every mechanism can be checked automatically, even if CSRF policies are in place, and all that further stuff can be tested as well. Even SQL injection can be tested here. Then do the dynamic application security testing at the top level, and on the most top level, you can also do some explorative security testing. Just check out some security charter, do a 1 hour based session with your developers, where the developers are allowed to put in each and every rubbish they can find in each and every input field they find. So this can have tremendous results if you just try to break things by putting lots of stuff in input fields. Then do your security code reviews, and yeah, as usual, let professionals do pen testing on your application. So that's all what I had to tell, so just in time. So thank you very much.
Yeah, thank you so much. It was a wonderful presentation, and we don't see any questions at the moment, but there will be questions coming up on the YouTube channel. You can, and for the speaker, for the listeners, you can ask your question, and Andreas would be able to answer it on the chat. And stay tuned for the next session. Next session will start in a couple of seconds, not even minutes.
No.
Thank you for joining. Thank you.
Thank you. So bye.
Yeah, thank you.